Hello, everyone. Namaste. Good afternoon to everyone. Welcome everyone to this event, which is known as Unfold UI and presented to us by Thoughtworks. So hold your gears and let's start with it. So my name is Gaurav Singh, and I'm currently working as a senior UI developer with Thoughtworks. And I specialize in working with PWAs, web components, and React, Angular. So this is what I've touched upon. So today's internet is basically full of content getting created everywhere. There are about 1.13 billion websites on internet to support that in 2023 right now. This whole process of converting basically this raw content that we have via rendering to get it to us via pixels is described as life of a pixel. And that is the topic of today's talk. So to understand so I'll be sticking to Chrome's architecture because Chrome is getting used, like 65% of users in today's world are using Chrome. So to understand how Chrome's architecture has changed for good to render those pixels, we'll first look at generic architecture of a browser in terms of process and thread. All the browser vendors, basically they work together in tandem to decide and share about various architectural changes, new standards, and all the challenges they are facing. They share almost same building blocks, but their architecture somehow differs when you use Mozilla, when you use Safari, when you use Brave for that instance, which is very new. So only the permutation and combination between these different blocks changes, and hence the architecture differs. So generic browser architecture looks like this, where we have common blocks such as device process to connect to your devices, renderer process, that is the main part of your rendering engine. Then we have storage process to access your storage. Then we have GPU process, plugin process, UI process, browser process, and network process. And of course, they are related to each other because they need to talk to each other. Those processes do inter-process communication and they talk to each other. But the thing is that for low-end devices, they use basically a mechanism that is known as servification. That what it does on your lower-end devices, what it does is it composes your maybe network, UI thread, and storage thread all into browser UI. So in gist, if you see, we only have to care about these yellow marked blocks. That is basically the most common building block of any browser's architecture. Moving on from user's perspective, we can see that if this is a browser, it's a very generic browser. And where this process stands, so this points to browser process. So this part where you see the body of your content, this points to your renderer process. Moving on, we have plugin process, and then we have GPU process. So these are your most common blocks of any architecture. The renderer process is basically the crux for what we call rendering of pixels, which consists of main thread. Then we have worker threads, followed by compositor thread and raster thread. So these are your part of your renderer process where rendering happens. Now we'll see exactly how Chrome is handling rendering for us via two important processes, that is your renderer process and GPU process. We are not talking about browser process and plugin process because very small part actually. So initially, if you look at the old architecture, that is where we have moved on, and Chrome is of course every day changing stuff. Initially, HTML is taken as an output into your renderer process. It goes through different stages of DOM creation, style and layout calculation, painting, composting, and rasterization and display. And this is how basically every stage here, so these DOM, style, layout, these are different phases of your process basically. And it is running on main thread. Apart from main thread, we have compositor thread. There other phases happen. So every stage creates a tree like DOM tree, layout tree, paint tree, scroll tree, which acts as an input for the next phase of your process. And hence, these are the stages which we use in your input, and finally you get the pixels on your screen after all those data structure passing through all through those blocks, pass it to your GPU, and GPU basically renders the pixels for us. So what were the challenges that we were being faced with this old design? So the first one which was highlighted was high memory and CPU consumption during your painting and composting, because we want 60 FPS animations, right? Everyone talks about 60 FPS, and we need 16.6 milliseconds for one frame to render. So I'll be able to do that every time. Suppose when I'm opening a web view, am I able to get the same level of a performance? So these were the challenges for a browser. We don't think about it, but browser has to cater to a lot of vendors and a lot of scenarios, so they have to take care of that. Then there were many layout issues. You must have seen there were many layout issues, flex and your block layout. Margin collapsing is just not your feature, but a bug, basically, if you know about margin collapsing. So they were not able to solve it. And it was in pending for maybe 10 years. So you can see that this is a list of bugs which were for a long time there with Chromium team, basically, and they were not able to solve these things. Extensive use of CPU for all the rendering tasks and basically missing out on using your GPU, which is basically capable these days to do a lot of stuff for you on your devices. Then the major part was messed up Blink pipeline phases. Suppose you have to create your general Go CD pipeline or some pipeline. Would you like your pipeline to look like this? That your functional test, something gives you, and anything can change your functional test object. You don't want that, but that is how actually Chrome was working, and hence Chrome was facing a lot of issues in terms of performance. The features that were exposed for developers, the developers API, were often not user-friendly. And they were not stable, scalable, or maintainable in that case. So it was a very bad experience. Also, there was less reliable audio and video playback on web, and of course, we want to see a lot of videos, so it was not performant and hence not reliable and scalable. So what was done? So basically, Chrome came with a project, and they named it renderingNG. So you must have seen that. It starts with your layout phase, basically. DOM and style, and these things are not touched because they were already performant. So Chrome came and they said that before rendering NG, we could and did add rendering features and improve performance, but struggle to make those features reliable for developers. And there were many performance cliffs. Now we have an architecture that systematically squashes many of those problems and also unblocks advanced features that were not considered feasible before. So definitely it was a win-win situation for them, and hence they moved on with it. The renderingNG product was broken into many modules as execution strategy. This includes composite after paint, layoutNG, blinkNG, GPU acceleration everywhere, threaded scrolling animations and decoding, Viz, and the last one is videoNG. These are the major ones. There might be more modules, but these are the major ones. LayoutNG, if you can see, it starts at your layout phase, and the thing which they had to work on, they have to always work on fallback because we are using browser, and then they have to update stuff. So they named a fallback library, which was known as LayoutNG, and they call it next generation layout, basically, which will help them to maybe not think about layouts in next 10 years or 15 years. Hence, they call it NG, the next generation of layout. This was layoutNG. So composite after paint. Currently, composite process happens before paint, the older version of Chrome. But now we can see that what they're trying to do is they want to move this process after the paint process and not before the paint process. Hence, composite after paint. So these are a few examples that are going on. So currently, we see that before, it was a big mumbo jumbo process happening right there. So nothing was in hierarchy and people were not able to evolve. So this was really looking bad. So what did they do? So basically, thankfully, renderingNG was there to save Chrome. In new design, all rendering stages should be pretty much functional. That is, there should be defined inputs, defined outputs, and a very deterministic behavior. Apart from that, all the rendering stages should follow WOMI, that is, written once and read many times. So we don't have to, basically we have to maintain the immutability for all the stages that are done. This is the new architecture, basically just like a rocket ship. So just like a rocket works, one stage is dependent on second stage is dependent on third, and no one bypasses any stages unless it's necessary, but it can bypass. So this is basically your so if you look at how things work, you must have seen this diagram where scripting happens first, then styling, layout, printing. And so basically the new architecture, what they did is they broke it into 3 parts. One is main thread, compositor thread, Viz process. And they describe scripting, styling, layout, and painting on main thread, animating, composting, and any scrolling activity on compositor thread, and raster and drawing to screen is done on Viz process. And now we do not have any GPU process as such. So the rendering architecture uses basically three terminology. Why I'm telling you this is because I understand we don't use it in day-to-day life. So what are those terminologies which you often hear is browser process. Browser process as a renderer, because browser process has your URL history, browser, those things also render, right? So you have to change the URL, unfold UI, pixel live. So those things are done by renderer of your browser UI. And then we have a compositing thread helper, which helps to communicate between browser and your renderer engine, right? The renderer sometimes sends new data, new SEO data or something like that. So they have to communicate. The second one is your renderer process, which has main thread, web workers, main thread helper, so they are demultiplexers and different thing. And we also have a compositor. So compositor is the crux where the improvement is with Chrome. And the last one is your Viz process, which is a combination of your GPU main thread and a display compositor thread. That is where the improvement is. And they have changed the naming basically here. So the rendering pipeline, so this is your rendering pipeline, just we saw like a rocket. I have removed the rocket and I've made more what kind of tree they are emitting. I told you that they will give you a data structure, which will be defined and that is immutable. So you can see that it starts with rendering pipeline in here, but the catch is that you can see that we have orange one, which is a Viz process, yellow one, which is a renderer process compositor, and then green one, which is a render process main thread. But why there are two phases, which is animate and scroll, which are with both colors? So what's the catch? So the catch is few properties that do not affect layout can also be worked out by layers via compositor. So their thing is sometimes I change some property and that is not affecting my layout. Then why am I squashing my older data structure related to layout? So they use property tree basically for that. So property tree is a new data structure that works on composting layer. By that means main thread doesn't get blocked. So all your scrolling and every other things, transform, clipping, all works on your composting layer and your UI is maybe janky free. So we'll start with the first phase, which is animate. And animate, you can see it basically changes your computed styles and mutate property tree over time based on declarative timelines. So they get a data structure and that data structure is passed on. And we see that if I want to animate and make a 60 FPS basically animations on web, what should I do? So basically you should always use as a default transform properties using scale, rotate, skew, matrix, translate, opacity. And there is a basically other property provided by Chrome that is known as will change and translate Z. So basically by default, it elevates all the content to the top layer and hence you have many layers and scrolling is never an issue. And you can get 60 FPS animations basically. These properties when using animations would run directly on your compositor thread. Style phase basically applies CSS to your DOM and create computed styles. It has not changed a lot. Then we have a layout phase that creates layout tree, immutable fragment tree, basically they call it. It basically determines your size and position of your DOM element on your screen, basically. So once you have to paint, suppose on your canvas, you decide that I have to put that at the top right. So they'll decide what the coordinates are there. So basically those fragments you can see, block is a block flow and there is a coordinate basically. And which kind of block is an inline block or maybe flex or whatever. So they create these things here. Once we have a layout, and of course, these are the properties that change your layout, position, width, and height. If you are changing these, so what will happen is layout will affect your pre-paint stage as well. So we should always think maybe opacity can work for me rather than a background color change for changing my blurriness or something like that. So we have to think how we can use these things judiciously. And another is a pre-paint, where basically we compute property tree and invalidate any older changes that we had. Then we get a scroll tree. So scrolling was a very big issue. So what they did was they have elevated this phase as a scrolling phase. Previously, we did not have any scrolling phase because right now you see there is a website embedded inside a website and inside website, there is more inside website of inception basically. So what they did is that they help you giving you layers basically, but we should never basically overutilize using layers that for everything we are creating layer. Of course, it will create overburden because your GPU will be overutilized then. So we get here, we create that scroll tree. Then we get the paint tree, which gives you display list, basically display items. So these are basically commands that tells you to raster something or commit something, basically to draw something. You can see these are commands: rectangle, paint it as a rectangle and put it in which order. So that order So if you want to change anything on your paint layer, you can use background image, text colors, or shadows. If you use this, these will affect your paint layer and not your layout and all. Moving on, we have a commit phase where basically all the changes goes to your compositor. Basically, compositor is a new thread basically that runs along main thread and helps you copy property tree and display. So basically, it always creates a clone of your main thread data structure. So by that way, suppose if any event occurs, it goes directly from main thread to your compositor and it doesn't stay on your main thread basically. So by that way, compositor has a full control and compositor can then tell your GPU that, okay, don't go to main thread, don't block anything. JavaScript is running. Please leave it as it is. And then please keep on scrolling something that I'm doing. So the janky experience is not there. So another one is a layer. So layer was a huge issue. Currently, if you go to Chrome, we have that functionality that every browser's layers can be checked. So if you go to your inspect element and you go to your application, if you search for layers, basically, they'll tell you that how layers are there and how they are creating those layers, those inspect things, because they have data structure for that. So that data structure is created using these processes. So we have a layer data structure now. So that breaks up your, basically, so now you have a, from layout tree. So this structure is created that will be used by basically my rastering or decoding or paint worklet. So it turns your display list encoded. So what it does is now rasterization, what it does is I have a big image. What it does is just think that you're cutting your images using a scissor basically. And suppose you have 10 image. So you can use different permutation and combination as how you, what your viewport is showing at that moment. So you don't have a fixed UI already created, but compositor, what it does is it creates things on fly for you. So hence, as you move and your viewport changes, what it does is they have created these styles. So these styles keep on getting added. So if you have a page and a canvas, which is 1500 pixel, that does not mean that we have a canvas of actually 1500 pixel. We break those things into tiles just like Legos, and those Legos can be used into different permutation and combination. Hence, rasterization, decoding, and paint worklet turns your display list encoded images into your commands, basically, which can be used by GPU as an instruction to store it into their shared memory buffer. So
God, your voice is breaking a bit here.
Yeah, sure. So the next stage is activate, where we say that, okay, whatever I want to do is fine, and I want to send it to my GPU, and GPU can basically see that what work it can do to draw all those things. So what they do is they create a compositor frame. So there are different frames that are created to draw basically. So what they do, they create a global compositor that talks with your browser process, renderer process, that what needs to be changed. And hence the final output with different layers, basically, they can aggregate. And the last stage is they will create this compositor frame, send it to GPU, and the display compositor, that is a part of your Viz, basically, that I told that there is a GPU has a display compositor in Viz that will aggregate, and gladly they will execute the aggregated compositor frame on GPU to create pixels on your screen. So we use OpenGL. Previously you used to use OpenGL or Vulkan. Currently we are using Skia renderer basically. So anything that happens on your renderer is a C++ or C code basically, and they uses your OpenGL previously, and now they are using Skia renderer, or they also used to use Vulkan if I can remember correctly. So they help you to draw these libraries will help you to draw pixels on screen, and very gladly the user can see the pixels on the screen via these changes basically. So that is the end. And in a summary, if you see what exactly has changed. So if you see previously we had browser process, utility process, GPU process, plugin process. So any extension that you download basically is a plugin. If you can want to understand a renderer process, every tab is a renderer process. So if you close one tab, your other process doesn't get affected. And of course there is isolation and security issues are there for creating different renderer process for your different tabs. Currently also those things stay there, but the change happens in your composting phase. That composting is now shared among Viz process, browser process, and your renderer process. You can see that everywhere composting is there and they communicate with each other, but the main task of composting still lies with renderer, and the painting part or drawing part stays with your GPU basically. So now we can leverage GPU in a better way. So I think thanks a lot for lending your ears and also for being such an attentive audience. I wish you a great day and weekend ahead, and thanks once again. And yeah, if you have any questions, I'll be glad to answer that. Yep. Thank you. Thanks a lot, and have a great day once again. Bye.
Thank you, Gaurav. Do we have any questions right now?
One from Pune. My question is more about the DOM tree, like the Angular as a traditional DOM, React uses virtual DOM, even Vue uses virtual DOM. So in this whole architecture thing, how does virtual DOM come into the picture? Like if you have to explain, like how does virtual DOM come in this picture?
So you're talking about virtual DOM, if I'm correct?
Yes, yes.
So virtual DOM is a concept that is specific to React. So in terms of browser, we have shadow DOM and not virtual DOM. Virtual DOM just is a replica of your data structure. So what we do is we always create an instance, basically n-1 instance before you want to update the n instance. So n-1 is basically not your DOM, but your virtual DOM. So what it does is virtual DOM always keeps on, that is your state of art algorithm. If in terms of React, they call it state of art algorithm. By default, it's an n cube of algorithm, but it generally, in certain cases, it works in n time. And they keep on basically comparing those virtual DOM with real DOM. And hence that diff is basically rendered and not all the things are painted or created, if I'm able to answer your question correctly. Yeah.
Is it okay? I understood your question a bit differently, but if you have signed it,
Okay. Yep. Thank you.
One question from Chennai.
Hello. Yeah.
Yeah.
So ours is an React single page application. And when I click on a specific button, let's say a page opens, which has too many elements and too many DOM nodes.
Mm-hmm.
In performance tab in Chrome tools, I can able to understand what are the JavaScripts that's getting executed and how long each function is taking and what's the time and how can I reduce, like what's the top 5% of the things that I can reduce in JavaScript, I can understand. Is there a similar tool for CSS in Chrome DevTools? Like where I can identify, okay, for layering, these are the things, these are the properties that's affecting too much, or for scrolling, or for painting, or for rasterization. Like, is there an overview of CSS performance where I can get a breakdown of, okay, this is taking this much, this is taking this much, and thereon I can take a decision on what to optimize and when, how to optimize?
Yeah, thanks for this question. So what I understand is that all this is handled by W3C. Any standard is created by HTML first, and HTML doesn't work on its own. Then we have CSS for that. So whatever changes you make in your CSS, any changes that go on basically is defined by HTML. HTML has different parameters. They're working group. Those working group gives you different data structure, and then they basically tell you that whether you can change any functionality that is in React or any other library, or suppose you want to layerize it or check it anywhere, you have to always conform to the rules that they have set. And hence React DOM tools also work on DOM that is rendered by them, and then they create their profiler over it. Or maybe they work on their own code also, and then they create the profiler for it. So yeah, I think you have to look for what web specifications are. And I think Chrome has a lot of tools. You can check memory. You can check unutilized JavaScript. You can check unutilized CSS. You can check what is your frame rate, what is your FPS, basically your frames per second, how much GPU you are utilizing, how much memory you are utilizing per maybe rendering time. So if you go to your Chrome panel, I would suggest all of you to go to your Chrome developer Chrome website, and you can see these things there. So this is nothing hidden and something that I know, but yeah, I can vouch that all those things are there for you to inspect.
That would be the last